So before we saw how to differentiate polynomials, or at least polynomials of degree 2, like this one. So if we take a polynomial of degree 2, we get this 2ax plus b as the derivative of ax squared plus bx plus c. So if we have b equals to 0 and c equals to 0, we have f of x equals x squared, and the derivative will just be 2x. And if we take f of x equal to x, that corresponds to having a0, b1, and c0, right? Then the derivative is just 1. Right? So one can show that in general, if you take a function of the form f of x equals x to the power n, if n is non-zero, then the derivative is just n times x to the power n minus 1. So that's what we see here. The green function here is the monomial, as it's called, and the red function here is the derivative, and in this case f of x is x cubed, or to the power 3. So using the power rule here tells us that to find the derivative we should take the 3 down in front and put x to the power 3 minus 1, so that's 2, like this. Then we can vary what n is, and it still holds this law of how to take the derivative. It's called the power rule because we have x to some power. As you can see here, the case n equals 0 is excluded. So what happens if you take any number to the power 0? Well, by definition, this is 1. So what is 1? 1 is a constant function, right? Something like that looks like this. So g of x equals to some constant. What is the slope of this function? Clearly it's 0, right? If we take a unit step forward, we don't go up or down. So the derivative of a constant function is 0. And this also works for the constant 1, which one can think of as x to the power 0.